Yeah, I started. You want. So let me put the link for the pad. Feel free to add any items to the agenda. So the first item is what do we need to do so we can enable it by the default upstream. I don't have Sam here, but I do see Patrick. So I know we are gonna do fixes for the encoding, right? And also we're planning to do, well, Sam is doing some cleanups. So thank you for Sam. And also we discussed cleaning up the pointer to the monitor. And I need to look at the notes. So we have a list of items to clean it up. We already have tautology tests for NVMe, and we'll need to run the Redis suite with the NVMe Paxos service enabled. Anything I missed?
Wait, I'm not familiar with cleanup of the encoding, and we did what we need to do already, so I'm not sure where it's coming from.
We are doing it. I haven't seen it merge upstream, so we need to merge.
It was merged by some already.
Ah, okay. No, Leo needs change for the bug upgrades.
Oh, for the upgrade, yes. For the upgrade, it's work in progress.
Yes, I'm fixed for the upgrade. Yeah, I'll add it. Okay, next topic is mine. Is everything, probably I missed some, that we want to do in SPDK. So we need, well, it's actually already is work in progress up a bit upstream for SPDK. There's a new NVMe cancel command. We need to support it. We'll need to work with the SPDK community for the implementation. It won't be full cancel because RBD doesn't have cancel. So it's be only if the command is still in the NVMe queues. There was a discussion upstream with Ilya about Xcopy support. We need to see the performance because currently it's emulated by the SPDK, which means it's actually read and write. We'll probably use the RBD Xcopy support and see, or cloning, but it was using cloning. If we can use clone, then that's gonna be good. If not, we need probably more research and investigation. Right, Ilya? It's a clone, right? It's maps to clone.
Well, it depends on the semantics. I think I've asked Aviv whether it's an operation that extends to the entire RBD image, so to the entire namespace, or whether it's supposed to be supported on, on any given range of LBAs. If it's the latter, then we don't have any efficient way of implementing it. And by efficient, I mean, what Xcopy, what people typically think of Xcopy, where it's a server-side copy as opposed to the client side. We don't have that in RBD, so it'll need to continue to be emulated in that case.
That's I think it's a copy of a range in the same image. So I'm not sure we can do anything about it. We still need to investigate it.
We need to check. I think the main user is VMware, so we need to see what it does. We could do a clone, but we need to check. Another optimization is using a shared thread pool for all this, basically. The BDs that SPDK is using for all the Ceph contexts. This will reduce the amount of threads we have. If we have lots of, we can define for performance, if someone wants, you can do a Ceph context per namespace, and then we get lots of threads. If we have lots of namespaces, currently we don't do that, but a shared thread pool should be more efficient. We can allocate maybe more threads for the messenger if needed for the network. We can look maybe doing less copies, stuff like that. So hopefully, and it shouldn't be a very big feature, but this will be in SPDK BDev code. So SPDK, next item is no huge pages. So currently, I think we are, well, SPDK can support no huge pages. By default, we are using huge pages. Here, the main issue, we don't know what the impact will be. I would assume it will be an issue with for networking for sure. But basically, we need to benchmark and see what the performance are we getting and make sure everything runs with SPDK with no huge pages. This is more to reduce friction, as huge pages needs to be allocated before you run the gateway, and if you don't have enough huge pages, you'll have issues. So mostly I would assume that for someone who cares about performance, they would use huge pages. And the last item is there's a new scheduler for SPDK. It's called Dynamic Scheduler. By default, the reactor model, when you allocate cores for the SPDK reactors, they consume 100% CPU on those cores. It's really efficient if you have a lot of I/O and a lot of work to do for the gateway. But if you don't, you basically are wasting CPU. So the mode of dynamic scheduler, which is new for SPDK, is basically be adaptive. So when there's no load, it moves back to interrupts model. And if there's load, you switch back to the basically poly model of SPDK. This is very new for SPDK. So it's a bit, I would say, research yet. Maybe I need to say the status if it's GA or experimental. But it'll be interesting to see. This is especially good when you don't have enough CPU and you don't want dedicated core for SPDK. It will be more dynamic, and I think you still define a set of cores for SPDK, but it's more dynamic and can move between the reactors and the LibRBD threads. This is also like a research project. Seeing how we need to try to enable it, see what we get result, what performance result we get for using this new scheduler. And it can help also for if you don't have large systems. Oh, yeah, good question, Krishna. I'll share. Thank you. Is it, should I increase the font?
Yes, we are able to see it.
Thank you. So this next section is we have everything that is security enhancements. We have two. The first one is about authentication. This is already supported in SPDK, but we need to add the support in the actual gateway. Basically, have all the users' information and credential, or at least integrate with other systems. This is NVMe inbound authentication. And then we have namespace masking. So by default, you can mask a subsystem, say this host can access these subsystems. Namespace masking allows you namespace granularity and can say this host can access this list of namespaces. The main concern here is that it's lots of metadata. If you have lots of namespaces, lots of host is the initiator. You can get actually, you need to store the data somewhere. So it could be quite large. We'll probably store it in another ORMAP, not the one we have today. So, and if needed, we'll do some sharding. Any question about any of those features? So in general, we're going to look at performance improvement. This will be mostly done with other improvements. I would assume maybe all the performance work is doing improving LibRBD. We can learn from it. And I would like also to try Crimson to see how, because SPD, the gateway uses lots of CPU, so if there was this using less CPU, it can help us. We'll have more CPUs. And so we need to look at it. I know currently we also have need to look at the messenger, because in some cases the bottleneck becomes the messenger, and we cannot actually get more from the network. But this is for when you have 100 giga and more network. So those are things we're going to look as well. There's also work done Intel upstream of using offloading of encryption. So that's also be very helpful for the gateway if it has the hardware offloading. Aviv, do you want to talk about vVols?
Well, there are some APIs that we need to support as a target to be able to for vVols to work. So we need to do this work. There's nothing much to say about it. Yeah.
The next section is usability. I think we have lots to improve. First of all, we discussed moving to Ceph CLI. We already have a Python package for the gateway CLI, but we would like to use Ceph CLI as well. This is lots of work on the CLI part. Integrate it into Ceph using the Ceph APIs instead of directly gRPC. Improve command. For example, we add listener command, which is a bit friction. Users don't really understand what it means. We'll look at ways of basically making you need less steps to configure the gateway. One of the options is to automatically add listeners. Support more than one gateway running on a Ceph node. It's obvious we need more than one. Documentation for troubleshooting, that's a very good idea. Anyone will volunteer? So to add it would be great.
Yep, I added this topic. Wanted to discuss more on that. I think any of the common issues that users face while deploying, or even from a minimum hardware recommendation perspective, I think some scenarios would be good to document. I mean, if you're facing an issue on client side, how do we troubleshoot that, right? I think some of those things would be really useful. I mean, some of the common issues that any user can encounter or that we have seen upstream. We can start. I think it will be good to build that documentation. I was just checking it out. I couldn't find anything.
Yeah, documentation in general, we need to probably add a section. We need to improve the documentation. Actually, it's not up to date. We changed a bit the CLI. We need to update it. Yeah, very good ideas. Minimal hardware recommendation, client-side troubleshooting. We can add.
Even from a basic perspective, right? We create a pool for NVMe. What is the pool storing? What metadata information are we storing in that? Or, I mean, I saw the documentation where we install the NVMe target gateway, right? And we mention about the pool, but we don't mention what is the pool actually being used for. And just a general information, some bit of internals.
So any ideas you have or anything that is confusing, so maybe just open a ticket and you can look at it as well, or ping us. Email is fine as well. So we'll have that. Also, another option is a GitHub issue on the project, that also is probably easier for us.
Sure. Thanks for the feedback.
Another item we need to start looking is snapshots. And well, snapshots should be fine. They're working as is. We need. Let me look. So here we need some way to connect. When we actually replicate the image to another Ceph cluster, we need to also replicate the gateway configuration to the other clusters so we can actually do failover. This is something we need to investigate exactly what the data needed. I don't think we can do it automatically as easy. It's easier in things like OpenShift Data Foundation. But we can probably simplify or maybe at least have several commands or document what configuration needs to be replicated. Probably we can look if we can replicate the OMAP.
It's not enough. You need to replicate the images.
Yeah, the images are supported. RBD, yeah, you need to configure what we call snap mirroring in RBD. and then the images will be asynchronously replicated to another Ceph cluster remote in another region. But it's not enough because the NVMe OF configuration won't be replicated. So the data itself is, but not the rest.
So maybe we can replicate it also asynchronously all the time.
Yeah,
Same
but
way as
someone needs to do it. It's
Yeah.
not that.
Yeah.
Is there anything in the metadata that would need to change, like as far as it's being replicated, like any sort of gateway ID or thing like that? Because if it's especially if there is something like that that would point at the gateway as the kind of agent for doing this replication. We could, if it's a straightforward copy this object from a pool on this cluster to this other pool on this other cluster, then this could of course be done in Ceph. But I suspect there's probably going to be some adjustments that need to be made to the metadata so that on failover you can just quote unquote just failover without like a gateway that is completely unaware of the fact that it's a failover scenario, can just open those images on the secondary cluster without any kind of additional knowledge.
I guess the IP addresses of the listeners of the of the gateways needs to be changed between the sites.
Right. So that's the kind of thing that I was referring to. Because otherwise, even the gateway that is aware that there's been a failover, like they would somehow need to do it like on the fly, and that's I think much better if it's actually done as part of the replication process. But anyway, all of this just all this means that the gateway would need to be involved in the replication. So it's not just it's not like with individual RBD images where the replication is going to be happening like on the back end, completely transparent to the gateway. Here, the gateway would need to be involved.
Right.
Yeah, completely. Like I target and listeners for sure. Anything with IP address, it won't be the same. Also, I assume access control, the initiators will be different. This one is actually, I don't know, something I need to think, because you'll have, I assume when you do DR, the initiators are also new, so you'll need to, all the access control need to be set up as well, but with the, I don't know, new initiators, it's actually very complex. I need to think about it because the initiators, or will you have, the initiators and QN may be different.
Well, I think there's probably going to be like two scenarios. One is where the initiators remain the same, right? And it's more like have an application that is running somewhere, and then it connects to the Ceph cluster, which is now unavailable. So I fail over to another Ceph cluster. The application remains the same. So it's not like the entire data center together with the application kind of disappeared. And the other, so that would be the first scenario where like none of the MQNs would change presumably. And the second scenario is more like what we're targeting in the Kubernetes environments, where it's applications are running pretty much alongside the cluster on the same nodes, and so if that if the cluster disappears, that means that the applications are kind of gone as well, and then when you fail over, everything is new, not just the cluster, but also everything that used it. I think both scenarios are valid, and the first one is actually easier, so that's the one that should probably start with.
Yeah, but for DR, I cannot believe we'll have the same initiators. This is inside the data center. For DR, you have a new data center. You'll have maybe we can keep the same NQN for the initiators, like ask the user to create them. But it won't be the same host, because this is short distance, low latency protocol. So I would say most likely we need to think what we'll do. Well, if we have authentication and not using masking, that's easier actually, because that's credential and we can replicate them. If you use subsystems masking or namespace masking, we'll need to think what to do.
It really depends on the requirements, but it can be done either way. But the question is if the target site, for example, might have already defined subsystems or not. Is it like that we are not going to override existing subsystems when we are doing it, for example? So I'm not sure exactly what is the use case, but so I think
VMware, so you have one VMware cluster in Europe, and you have a synchronous application to the US. And if something happens to your cluster in Europe, you move the one to the US. In that case, everything is going to change. The R is usually for disasters. So usually you won't have the same initiatives. But yeah, we'll probably we'll have all the information. Like you'll know in advance the initiators and QA and stuff like that. Because it's actually running the VMware cluster. Or we're lost. Something like that.
Mm-hmm.
But it won't be easy. But at least I think it's for the mirror daemon to be a bit easier, because I would assume there won't be lots of namespace like we have on the ODF has lots of volumes they want to replicate.
We also need to replicate the Ceph ADM configuration for the gateways, the spec files probably if we want exactly the same.
Right. I agree. We need to think about the requirement. Yes, Krishna.
Yeah, I have few queries on the MTLS actually. Today, if you look at to create the server certificates, we are using the subject alt name as IP addresses, right? So we are like, when we do a scale up or scale down scenarios, every time we need to recreate the server certificate and client certificate and upload back to the cluster. So do we need to consider, instead of IP address, is there any mechanism to go with the DNS or something else we can do it here?
Yeah, I think we should just make the root certificate be work and not use the IP addresses.
Yeah.
Yeah, I think we can fix that.
So what will be the root certificate? I'm sorry.
So today it's like the client certificate. The client certifies the gateway, and the gateway certifies the client, right? And I think that's the reason why we need to specify specific IP addresses in the certificate that we create. But I think that if we will fix the code to, to have a root certificate, like a third party, right? That's a third side certificate that we will do the certification against. I think that will fix this issue.
Correct.
Yeah. Any other topics?
I have a question about the Ceph CLI thing. So my understanding is that you want to, like take more or less the same commands that the gateway CLI provides and simply embed them in the Ceph CLI under some prefix like Ceph NVMe or something like that. But you mentioned that this would be not gRPC, but something else. So is the idea like how would the Ceph CLI process to talk to the gateway?
It is going to be the same gRPC as far as I understand, but the
No,
Ceph, yeah, go ahead.
it's gonna use the APIs. It will go basically, this CLI will go to the API server, the Ceph API server, and the API servers will do this gRPCs. That's the plan, and you authenticate to the API server, not to the gateway. That's the current plan, but we don't have anyone from the team, the management team. But what they plan is basically we'll already have the API server because for VMware we needed the API, and basically use those API and not go for the CLI directly.
Okay, so it's still gRPC, it's just that it's not it's indirect. That makes sense. Thanks.
Oh, yeah. So the CLI will talk, it's REST API, it's not gRPC, it's a API. We'll talk with REST API to the API server, and then the API server uses gRPC. So it's also more secure because then gRPC is inside the cluster, and the API service, and you authenticate to the API server and not to the CLI, so you don't need, for example, MTLS. Or you can do MTLS to the API server and the gateway and don't need to manage this through all the clients, initiators.
Yeah, there is, maybe we can also add a TLS PSK. I mean, that's something that we're probably going to have in 8.0 code, but because the initiators don't support it yet, so probably it will be more usable in GA at Tentacle, because then probably initiators will already support it.
So we basically support the SPSK sort of, but the initiators don't.
Right. I mean, in Red Hat 10, they have experiment. I think in Red Hat 10, they have a technical preview of that.
It could be, it's 9-something, 9.4, I don't remember, but it's technical preview. The plan to GA, it only probably we need to get to sync with the team, but it's not. It's only available upstream currently, upstream kernel. There's no Linux distribution that basically has it. Neither Ubuntu, neither, well, I don't know about SUSE, I haven't looked, but you need very new kernel.
I think in Red Hat 10 they support it, but in technical preview, that's my understanding.
So this is even farther away. I remember 9 something, 9.5 or 9.
Oh man, we need to go back and check.
Yeah, I need to check. Let's. Yeah. Actually, we only put inbound authentication, but the next step is actually TLS ADMAC. This is like the next step. But that one, I don't think it's going to make Tentacle. It's like we need authentication for this, but I actually don't know any initiatives. This one is very complex. It's more flexible, less friction for the user, but very complex to implement and configure. Any other items, questions, comments?
I think it would be good to spell out the list of the APIs that are required for supporting vVols, so that if there is, because I suspect, or at least my recollection is that all of them are kind of already supported in librvd and wired up in SPDK. But if not, this would help to identify any gaps there, because add the APIs that are required doesn't say much in terms of what is actually required.
Yeah, we can add that.
Yeah, where I haven't looked at it. I think I saw Bill here. Bill, do you remember which API are needed for vVols?
So, I mean, there's some changes required in the NVMe target. So I think you have to have a distinct namespace for vvols, and you have to identify a vvol subsystem slightly differently. So I think you end up with kind of one system for vvols and another subsystem for non-vvols. So yeah, there's a few things like that in the NVMe code. I think vvol is going to have more requirements on librd, because some of the metadata it needs to store has to be replicated for the kind of DR snap mirroring with the same consistency as the block data. And so, if you intersperse write IOs with metadata updates, then the DR snap mirroring kind of has to take that as a single stream and have a single cutoff point in what it does and doesn't replicate. And then, the vvol replication needs to tie in with the work you're doing for DR snap mirroring, because the vvol interface is actually going to want to be able to trigger the failover to the DR site.
So okay, so now the metadata, can we store the metadata inside the image? And that will simplify our life, or do they have to be like two volumes or separate?
I mean, it would be simplest if we could, so the vvol metadata is all key value attributes. So it would be simplest if we could, somehow store those in the image that's got the data in it. Although, I mean, obviously an image volume consists of a number of objects, and so there's multiple places we could think about trying to put those key values.
We actually have support, it's called RBD image metadata, where key values are like user provided key values are stored on the image header object. And I think that it is actually replicated with snapshot-based mirroring. What I'm not sure about is the consistency guarantees. It might be that the way it's replicated is simply that like the snapshot is taken, and then the kind of the snapshot of the season values is like not really a snapshot, but they're taken one by one or something like that. So it may not be actually consistent with the snapshot taking on the image. That's something that would need to be checked. But some kind of rudimentary support for replicating RBD image metadata, which is really just user-defined keys and values, that is there. So at the very least, we have the building block, but it may need some work in terms of making it, in terms of making it so that it's consistent.
Yeah, okay. So vvol sounds very complex.
Yeah, but if we strip everything that's related to DR though, and just forget about DR altogether, what do we think there is something missing, or like is just a matter of kind of wiring up, or is it, you know, similarly to, for example, the problem with consistency, or, you know, the potential problem with consistency and many other edge cases? What is kind of the general view? Because again, we don't have a list of APIs, so I'm just trying to understand if there's going to be RBD work required here.
The other area we need to check for vvols and RBD is the snapshot interfaces and whether that has everything that's required. I'm guessing that the answer is yes, although we'll probably have to do snapshots and then clones of the snapshots, because VMware snapshots are not quite immutable. But yeah, we need to check. VMware needs the ability to kind of find differences between snapshots and potentially be able to restore those differences. So yeah, we'll have to kind of check the snapshot difference capabilities.
But is it specific to NVMe?
That's not specific to NVMe. No, that's all just the vVolt. That's a provider talking to RBD.
Mm-hmm.
So yeah, I think for the NVMe side of things, it will just be, you know, being able to have a subsystem that is reports itself as only reporting vVols, and you know, have an interface to be able to add and remove images to that subsystem. And then, you know, if you've got any limitations on, you know, number of host IDs for an NQN and things like that, then that may need tweaking.
Okay, I don't think that, I mean, if we don't do DR, I don't think that it's a lot of changes, but yeah, we need to look into it.
Yes, Sunil.
Yeah, hi everyone. So actually regarding that DR snap mirroring, even for now also, I think the images with mirroring snapshot, like we're able to expose that image to NVMe disk and then use it, right? Is it any really work needed from the NVMe side? I think Ile can you answer? You can answer, I guess.
I don't really understand the question.
Means right now, like whatever the RBD images with the mirroring enabled, that itself we can expose as a NVMe configuration and then expose it as NVMe disk, right? Why we once again we need to do mirroring from the NVMe images separately, because mirroring is happening from the RBD side, so there's no connection. I don't see any connection from the NVMe exposed disk and then RBD images there here.
So
It's
if
just
I understand, you're asking why do we need to do anything with RBD? So the user, when the user uses NVMe OF, he sometimes doesn't even know which RBD image it's mapped to. He knows the NVMe namespace and subsystem.
correct, yes.
And we want to give him the same experience. So when you do disaster recovery, you have all the applications set up, and it uses NVMe over TCP. So you need it to use also NVMe TCP. You can probably do like the simplest implementation. I would, if it's possible, I would say you need to find the image and make sure it's replicated. And then when you actually do a failover, create the namespace on top of that and connect the new namespace and everything new to that image. Yeah, it will be simpler implementation, but if you wanna talk about like full application, like with ODF, you will probably need all the gluing. But yeah, maybe we don't need to do all the configuration, but you still need to configure the NVMe OF gateway similarly.
Okay. Yeah, like maybe we can show it to user that these are the namespace images, like mirroring here. That way, it would be a good idea.
But the first
Yeah.
step, this like today, even today, if you know the image, you can configure snap mirroring and it will be replicated without any issue.
Yeah.
Okay. We need to finish. There's another session coming up. So thank you, everyone. Very productive, lots to do. See you next sessions.
Thank you.
Thank you. Thank you all.
Thank you.